Okay, today we will discuss how can we use dynamic data type, how can we work with the dynamic data type, control dynamic data type. So for that we will use waveform graph and chart. Come to the PC, create a folder, day 16. Open your LabVIEW, come here, create a new VI. Okay, one by one I will show you how I will write some example in front of you and I will try to give you some explanation. First of all, right click here. Let's start talk about dynamic data type. So here I am going to use for loop. In this for loop, I am going to give the control value here. I am going to provide a control value 100. Okay, 128. Right click, come into the mathematics, elementary, trigonometry. Take a sine waveform. Take here. Now divide this value with the n. Sorry, divide this n value with the value 10. With value 10. Make a connection. Okay, come here, come into the front panel, take a waveform chart and place here. Make a, try to connect a waveform chart here. It will, you can able to connect easily the particular waveform chart. If you will take a waveform graph and if you will try to connect that waveform graph with this value, so you will not able to connect. Okay, so now let's try to make a connection like this. So waveform chart we can connect inside, and waveform graph we can connect waveform graph with this array. Now run the program. Here I am going to put one wait time. Using the wait time we can control the speed of execution, so easily you can see the data changes. Hmm. That means you can see here this function will generate the data each and every second, each and every iteration. So we can easily able to display the data in the waveform chart. That means we can able to display the current data in the waveform chart. But waveform graph, if you have any data in the form of the array, so you can easily able to plot that array data on the waveform chart of graph. If you have some data in the wave array format, so you can easily connect that data, you can easily display the data in the waveform graph. Here I'm going to take two waveform graph, one waveform graph and chart. Look at here, and I will discuss with you related to that property, the core property of the waveform graph and chart. Now you can see here it is my waveform graph. When you will press Ctrl H and you will increase this platform, so you will get to know. Now you can see here the waveform graph is a collection of del t, t0 and y array. You can say x0, del x and y array. It is a waveform graph or waveform chart. In the waveform chart, you can see here we are only we can only put the data. Okay, sorry. Waveform graph is a collection of delta t0 and y array. Here you can see, and waveform chart. In the waveform chart, it's a collection, it is a group, it is a cluster of single value. It is a cluster of single value. Okay, now that's why we are here able to put we are here able to put the single value. Waveform graph is a response of display of the single value. Okay, and waveform chart is a response of the display of single element. Waveform graph waveform chart is a sorry waveform chart is is waveform chart can show only the current or instantaneous value, but waveform graph using waveform graph you can show the array kind of data. Waveform graph will provide you del t, means you can put your data with a specific time duration, but waveform chart will not wait for that specific time duration. It is a one example for the waveform graph and chart. Save this program. Okay, now here I am going to put the waveform same program. Now you can see the same example. I am going to replace with the while loop. Okay, delete this waveform chart, control B, take this waveform chart and place here. If you will try to connect the waveform graph here, so definitely connect. Create, control, run. Now you can see here, sorry, copy and paste. Now you can see the front panel for the okay. Now you can see the waveform chart is displaying continuously, but waveform graph is not able to display any data. Why? Because we know waveform graph only accept the array and it is present outside of your waveform. That's why the system is not able to display the particular data. So for that you need to press the stop button. After pressing the stop button, you will get the particular data. Now, suppose if I will take this waveform graph outside. Suppose let's take the waveform graph outside. Waveform chart. Sorry, let's take this waveform chart outside. Uh, take waveform chart outside and try to connect. So can we able to connect the definitely we can connect the waveform chart, and it will be again it will be display the data as like the waveform graph. Now you can see the outer waveform graph or waveform chart is not updating any data. Only inside the waveform graph and chart are updating the data. When you will press the stop button, so it will give you the particular data which is present in the waveform graph and waveform chart. Okay, there's one more fundamental difference you will see. Waveform chart has capability to display the past value. Okay, we know it history data. The waveform chart has the capability to display the history data. History data. Now, if I will move it, so you will able to find the history data of the waveform chart, history data for the waveform chart. But in the waveform graph, you will not get any history data. You will not able to find much history data. Okay, you can see here. Okay, sorry, it is not a waveform chart graph. Sorry, it is a waveform graph. You will not able to find the any history data. Okay, but in the waveform chart, you will get the history data. What is the core difference between the waveform graph and chart? Control H. Waveform graph can display. It is a collection of delta, T0 and Y array. Delta will give you the start time of the signal. Sorry, T0 will give you the start time of the signal. Delta will give you the time difference between the two data points, and Y array will give you that particular value which is responsible to display the data. Clear? Now, see. Okay, it's clear. If it is clear, so let's see how it works. So now, if I will take a data here, I'm going to take a data here. Let's delete this one. In the waveform graph and chart, right click, come here, come into the waveform. Here you can see here the build waveform function is available. Build waveform function is available. So let's take the build waveform function. When you will take a okay, before going to do this experiment, let's come and let's try to understand how we can take it. So press Ctrl and Ctrl T. Right click here, come into the sine waveform, signal processing, take a sine waveform, and take a sine waveform. Now right click, create a indicator. If you will create an indicator, and if this indicator is waveform graph, so you will able to plot this dynamic data. Okay, you can easily able to plot the sinusoidal, this sine wave, sinusoidal wave. Now you can see this sinusoidal wave. I am easily able to plot. If I will now, then you can see here in the sinusoidal waveform, we are getting, sorry, in the sinusoidal waveform, the time duration is 1 second only. The time duration is 1 second only. If I will change the frequency from 10 to 100, so still the time interval is 1 second. Time interval is 1 second, but I am getting the sine wave with, okay, now you can see I'm getting the sine wave, but here signal are not very smooth. The signal are not very much smooth. 0.04, if you will found, so you can, sorry, 0.04, 100, 0.04. Now you can see here the signal are not very smooth. Okay, let's take it 150, so we will get this smooth signal. Still, each and every time my time is axis is giving the 1 second. Let's try to break down what data we are getting. If you will right click on this data and you will create an indicator, so you will get to know here we are getting time T0, delta and Y array. Here delta is 1 millisecond or 1 microsecond. Here delta is 1 millisecond. Right, 1 millisecond is delta. Means each, in between each and every signal, in between each and every data points, the time difference is 1 microsecond. Okay, in between each and every signal, the time difference is 1 microsecond. You can see here between each and every second, sorry, between each and every data points, the time difference is 1 microsecond. I hope you are able to understand this small time, okay, fraction. Now, that's why a waveform graph is a collection of three different things, delta, T0 and Y array. Now, right click, come into the waveform graph, come into the get waveform component, right click on the block diagram, come into the waveform, take the get waveform component, place here. So by default you will get, it is giving you the Y array. But in place of that, if you will find, if you will try to click here, so you will get to know there is one select option is available. When you will try to select the option, when you will click the select option, so you will get T0 delta and Y array. T0 delta and Y array. Click the T0 delta and Y array. Okay. When you will click on, if you drag it, so you will get attributes, attributes, attributes. Here I am going to select the T0, here delta and Y array. Now, I want to know how many sample points are available on this signal, or how many data are available on this signal, how many sample points are available. So for that, I can come into the array and I can take the array and I can find out the number of sample in particular signal, the number of sample in the particular signal. That is 1000 sample. The distribution is the 1000 sample. That's why 1000 sample is the distribution here. This signal we are getting the 1000 sample. Okay, here number of sample to read is 1000. So let's try to find out the sampling rate. How can we find out the sampling rate? Here we here you can see here, to display the 1000 sample, to display the 1000 sample we have, okay, it's taking 1 second, it's taking 1 second. So tell me, what is the sampling, what will be the sampling rate? So for that you can know, you can right click. How can we find the sampling rate is 1k? So for that, come here numeric. You can take the square reciprocal function, place here reciprocal function, make a connection with the delta, create indicator. Okay, how? Okay, now just you want to know, if delta is this, if delta is how, what is the delta? What time is the delta? What is the delta value? The delta value is 0.1. If delta value is 0.01, so, and if you have the array, if you have the delta value and if you have the array, and you want to check how much second it will take to display the data, okay, so for that you can come here and you can multiply the delta along with the count of the sample, so you will get 1 second. That's you are getting here. Hmm. Because it is a system simulated hardware, that's why. Okay, now press Ctrl H and click the sampling rate sample, right click, create control. Now please tell me, are you able to see what is the sampling rate? Sampling rate is 1000, which we had extracted here. It is sampling rate. Sampling rate, number of sample, number of sample. I think we are able to, I think I am able to explain properly, because same thing we are getting here. What happen if I will change the sampling rate from the 1000 to 100? So my expectation is, here I will get 10 signal, Here I will get 10 signal. The sample will be them. Here will change and this will be changed. Now you can see we got the 10 sample. Now the delta has been changed automatically and that is 0.1. That is okay 10 millisecond. Okay. Now if you want to count how many samples are greater than 0, then what you will do? How many samples are greater than 0? So for that, come to the comparison, take a greater than and equal to 0. How many samples are positive? Then take this function, it will be count. Then you need boolean to boolean to 0 and 1 converter. I think you can remember easily, very easily. Then you can take uh, add array element function, and you can say that the dear user, the number of positive elements in the signal are 500. Sir, I want to eliminate all the positive negative number and I want to display only positive number. So what can I do? How can we say that if any number is greater than equal to positive, so then you can say that particular number is a positive number, right? If the particular number is greater than equal to 0, then particular number is positive number, so you can easily transfer. Okay, and after that you can right click here and you can come into the conditional, and this condition we need to put only when the number value is greater than 0, then it will be, then the particular signal will okay give you the particular number. Selection is not a correct option, sir. I will let you know where we can take the selection function.
सर वो टनल कैसे चेंज किया उसको फिर से दिखाइए एक बार.
First, now right now it is this tunnel. Now this tunnel is all about the auto index tunnel. When you will right click, you will get tunnel mode and their last value you know very well, concatenating and conditional. So when the condition will satisfy, when the condition will true, it will pass the data. Now if I will take a waveform graph here and I will try to put the data with my this data, then I will get only this. Okay, now you can see here I'm getting only half data. Now you can see here I'm getting only half data. I'm not able to clamp. Suppose, as you said, if I will take a select function after that, and if the particular number is greater than 0, and after that, okay, then place the data either just just pass a 0 value, constant value 0, then how it will look like. Then at that time I'm going to show you how it will be look like. Control Z. Okay, how the system will look, that I am going to show you. At that time the signal will look like this. If you want to make your own rectifier where you want to select the particular signal, the particular sample will greater than and less than 0, then right click, come here, commit the array uh, comparison, minimum and maximum in a range or in a range. Take the function, make a connection with this value. My maximum range, fix the create control, con create constant. Maximum range is maximum range I want to put zero point 0.7, and minimum range I want to put, minimum range I want to put here, create constant here in this function. Okay, include the upper limit. Then how it will be behave in lower range, minus 8 point minus 0.8. Then how the signal will look like. It is not connected right now. Now you can see I can easily break down all the signal based on my given value. Clear. Hmm. Let's come here. Right click here. Right click here. Here, if you come in the signal processing, filters, Butterworth filters. Mm, 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 mm. Okay, now just a second. Signal operations, windowing, transformations. Uh, Are you able to see the power spectrum density? Please help me to find out. Yeah, power spectrum, then okay, power spectrum. Okay, power spectrum. Let's see. Let's take the signal here. Can I display this data anywhere? Now you can see what it's showing me, what frequency I'm get. Okay, what it's showing me, what frequency I'm getting here. Not in this one. Press Ctrl T. What frequency is showing me? Can you please tell me? Here I am getting the frequency 10. Here I am getting the frequency 10, right? Let's try to come here. Sorry, 1. Sorry for my well. Okay, one 10. Mm-mm-mm. There is any problem with the signal? Sampling rate is fine. Okay, just a second. Na. Uh, let's proportionally do this signal. Okay, 1K. Now we'll get the correct answer. Alright. Okay. Now you can say, see, my signal frequency is 1. Now you can see my signal frequency is 1. Getting point, sir? And what I had just used the power spectrum density functions. Okay, what it's giving me, it will give me the error. So if you want to find the natural frequency of the particular signal, so it will be able to possible or not, that is the my only option, only option. So if I will come into the array or comparison, if I will use a minimum and maximum, and maximum value, minimum, maximum, no, there's any array functions is there, minimum, maximum, control B. Let's take a array minimum and maximum functions. So I can create a maximum value, create a indicate, sorry, here, index of the maximum value indicator, and I can put this number, it is a natural frequency 50. In the main case, in the main scenario, let's go there. Let's come, okay, let's go up together. Okay, let's come here, right click, create change it to the control. Right now, if my signal frequency is 10, right now, if my signal frequency is 10, then I am getting the 10 signal. Why? Because the sampling rate and sampling rate and number of sample to read the both distribution is same. That's why I'm getting this 10 sample here, and here I am able to find out the particular sampling rate. If my sampling rate will be okay, lower than the my number of sample to read, so my system should wait to collect system should wait 10 seconds to collect all the 1000 data. In that condition, my frequency will be completely changed. Okay, try to write this program during the practice, and try to get the solution. If you will face any, if you will
Sir, sir, is this related to aliasing?
aliasing,
Yes,
uh,
aliasing.
okay, aliasing. I didn't think about the on that point, because I'm not here working on a directly signal processing. Okay, and here we are also not doing that modulation. Here I am doing, yeah, aliasing. Okay, let me work out once. Okay, let me think, because without coming to any specific or any uh, concrete logic, I cannot comment anything, because I didn't think, because all these things I have done during teaching and teaching time. Okay,
सर आई वांट टू लर्न लिटिल अबाउट aliasing. थोड़ा सा प्रिपेयर करके सिखा दीजिएगा.
okay, definitely I will try to that help you out about the analyzing. Sir, you are professionals or academics, sir? Industry or academic, sir?
सर मैं इंडस्ट्री में हूँ और कुछ इंस्ट्रूमेंट्स डेवलप करने की कोशिश कर रहा हूँ.
In which company, sir? If you don't
एनडीटी
mind.
लेबोरेटरीज कलकत्ता मेरी कंपनी है.
Okay, okay.
And we are trying to develop some inspection instruments where we take sampling data from sensors that
Okay.
detect the crack on the steel pipe or things like that.
Okay, okay, okay. So you okay? Thank you. Uh, because all these things are not a part of our this training. Invest your time here. Definitely, you will get to know. You will able to learn many things. Save it.
Yes, sir, definitely. All this is useful for me.
Okay. Suppose now come here. Suppose I want to start my data with the current time. Put take here timing current time. Okay. Okay. In place of that, let's start from here. Right click. Come into the waveform graph. Take a build waveform function. Delete it. Okay. Drag it. Del t t y t. Okay. And y array. Make a connection with this. Keep the distributions constant. Here I want to keep the distribution 0. And I want to give the today's let's say we have this timestamp and I want to give the timestamp here. Now make a connection. Control B. Okay, it's a waveform chart. It's a waveform graph. Let's try to plot here. We have this space. Run. Okay. Now you can see here my system is working. Set the time now. Today's time. In 1 second we'll get the signal. We are getting this signal. If I will try, so I can get the entire data if okay entire data here. Okay, I'm not getting, no issue.
Sir, amplitude range is wrong in the build waveform chart. Amplitude on the left side, the amplitude scale, the Y scale. Yes, sir. These values should be, I think, different.
Hmm. Okay, no issue. I will manage. Okay, right click, come into the properties. Okay, visual plot, absolute time. Okay, run, absolute time, run. Okay, so can I able to see the 1,000 points here? Okay, one. Just second. Here I'm going to put the 0.1. The distribution will not move. Now you can see here we are getting the proper signal between the particular time range. If you don't want to go with this, give the absolute time. Okay, रन, अभी का टाइम सेट करता हूँ. लेट्स ट्राई टू काउंट. यहाँ पर देखिए, between 1 second we are getting all the signals. In between this second we are getting all the signal. If it is 0.1, 0.1, and if I will run, so I will get the signal like this. You can see here. Okay, for the to placing the 1000 sample, it's taking the, and you can see the time is varying here from the 46 seconds to last signal you will get here. Now it's not a perfect, just I want to show you some, just I wanted to show how can we control it, how can we build it. If I want, I can go behind this, right click, come into the cluster, build function, take the build functions, create, take a constant value that will be del 0, take this value that will be don't here, make a connection with this, it will be a 1, and then array, remove all this and make a connection like this. Okay, now look at here, control B. Waveform graph will not accept, no sorry, waveform chart will not accept this data. Okay, only waveform graph will accept this data. Now you can see here, only waveform graph will accept this data. Now the distribution you can see here. If I will reduce the distributions here, 0.1, so you will find the signal with 13. If I will tell here 10, 1000 data and 0.01 point, okay, it's a build. I hope it is enough for today. We'll meet again tomorrow and we'll work on the other topics.
Okay, sir. Thank you.